friends. Welcome to Coding Garden with CJ. Welcome to Code Wars Code Katas, episode 42. Well, we're gonna break things down one step at a time. We're gonna solve these katas, you and I. We're gonna break things down one step at a time. We're gonna solve these katas, you and I. Code Wars, Code Katas, Code Wars, Code Katas, Code Wars, Code Katas, yeah. Welcome to the show. I'm very excited that today is episode 42. 42 is a great number. Yeah, it's a good thing. So if you are new to the show, visit github.com/codinggarden/code-katas. You can see all of the solutions from past episodes, and all the solutions we solve and all the problems we solve will be uploaded there tonight. If you're new to Code Wars, you can go to codewars.com and solve coding problems. They range in difficulty all the way from 8Q, which is the easiest, all the way up to 1Q, which is the hardest. And tonight, maybe we will revisit the 1Q that we tried to do last time, but didn't do very well. That's something that needs to be done. But also, we might just take it easy and try some other things. Maybe we'll put a time limit on the 1Q. I don't really know. But welcome, everyone. And yes, Merritt Chan has it. This episode is the meaning of life, the universe, and everything. Hope maybe we can find a kata that's like Hitchhiker's Guide related or something like that. Hello, Joe Mama. Hello, Ricky. Hello, Daniel, who gets to watch me from home. That's good. Thanks for the follow, 66. I agree, Daniel. So yeah, Twitch has this new moderator view, and it's pretty slick. I wonder if this needs to like be refreshed. Yeah, so this will like show you users in chat, and there's an auto mod queue. It's pretty sweet. I like it too. It's my first time using it, I guess, during a stream. The rules here are be nice to each other. This is a fairly family-friendly stream. And as I mentioned, we're doing Code Wars Code Katas today. Katas. And what's up, Alka? It's been a while. Welcome. Greetings, Serdar. Welcome. Hello, T. Hello, Abhishek. Yeah, I guess... Oh, let me enable the drop game while we're on the screen. Yeah, Acid Spark has not made it onto the leaderboard, but yeah. See? Yay. Hello, Happy Phone. We are the seeds to the future. I agree. And hello, Extra Fez. Well, that was unexpected. Hello, Davila. Wow, face dude. Code katas. Yeah, that's what we're doing. Yeah. Oh yeah, so Heck is working on a background for this screen, because right now this screen is very boring, right? It's just Coding Garden logos. So Heck does pixel art, and so she's going to create like a secret garden that's going to go behind me, so that'll be pretty sweet. What makes 42 a great number? Just the reference in Hitchhiker's Guide to the Galaxy. That's about it. Hello, Vladimir. Yeah. Laugh it up. Hello, Happy Phone. 1Q, we might. I don't know. That 1Q from last time really took a toll on me, but Doc so graciously has provided a rundown of how we can solve that 1Q problem. And so we might do that. But again, we might just like set a time limit on it, so I'm not working on that same problem for like 3 hours, but we'll see. Quarantine life. Hello, Sejin. Hello, Acid Spark. Why are katas important? It's just good to practice solving different types of coding problems. And Code Katas is, or Code Wars is cool because they have different categories like fundamentals or things like language features. And they have a lot of different languages that they support. So if you're trying to learn a new language, it's a great place to do that. If you're trying to get better at a language, it's a great place to do that. Hello, Rao. Hello, Dow. Yes. 42 people watching right now? Okay, it's a little more. Oh, thank you, Alex. Yeah, I do plan to revisit that, most likely this weekend, maybe? I always say that. I don't know. But I've been doing some streams where we're talking about a SQL database and implementing it, so we'll definitely revisit that soon. Code Katas, this is the first Code Kata stream since the coronavirus got so intense. It is. Hello, Kiana. Welcome. Well, thank you, Daniel. Those logos are not boring, but they're not exactly exciting. It's the same thing over and over. It's just repeated. So it would be nice to have like a secret garden or something like that, you know? Heck is actually the one that designed the coding garden logo. So yeah. Hello, WebTech. Hello, Azerbaijan. I can do. I guess I'll try. I think I'll dedicate at least 1 hour to that one queue problem that we didn't solve. I guess that was 2 episodes ago, but we'll see. That'd be great. I don't know if you're interested, Doc. But yeah, it'd be fun to pair on stream. Maybe you can help me out with like a really tough problem. Oh, nice. A placeholder asset. That looks great. Yeah, I know. Heck uses Sprite, which is like a pixel art thing you can get on Steam. But yeah, Secret Garden pixel art might not. Okay, we won't Google that. The Twitch logo with the number on it is the number of followers on Twitch. What now? Welcome, Ryuki. I didn't see fully what your name was. Animate the logos. I guess that'd be cool. They could be like dancing around. I don't know. Yeah. And hello, Strinkies. It's pretty good. I had a good day. Did a lot of work today for my job, my actual job. And I had a product demo today, and it went really well. So that's good. I found a coding challenge website you can play with other people, and it's pretty interesting. Yeah, I was actually thinking of doing this because there's that Clash of Code website. Maybe we warm up with that. That might be fun. Let's actually do that. So it's the site where we can compete. There will be a room that we all can go into, and then we'll compete to solve the problem. We've done it a couple of times on stream before. Let's see. Clash of Code. Here we go. All right, let me finish saying hello. Hello, Ajith. Hello, Plu. Hello, Noah. Oh, thank you, Plu. The not so young amongst us remember the hamster dance. Maybe. So they could move around. I think a secret garden would be cool because I usually go to this screen when I'm like displaying environment variables or something like that. So yeah. Ooh, a COVID tracker. I'll check it out. Let's save it for a little bit. I did, Plu. Okay, so let's do this. Raise your hand if you'd like to participate in this Clash of Code. Actually, can I create? Yeah, start a private clash. Here we go. Okay, so here's what I'm going to do. I'm going to share the link, and then once you get there, you might need to... I think you can sign in with GitHub. But the first, 4 times 3, first 11 people to make it will be able to compete. There's Alka. He's going to compete. Tony is asking if I have time, make a live stream on how to debug problems. That would be interesting. I've thought of collecting of all the different possible errors that can happen in JavaScript and what they mean, but that would be interesting. Hello, Greg. Welcome. Oh, thank you, Hedemi. So if you follow that link, you can attempt to solve this coding problem as we do it. Let's see. Tips on data structures. We could talk about that in a bit. Make sure to click join at the bottom. Yeah, so there's a few. Welcome everyone. Those of you that are just joining, here's the link again. If you go there, we are going to clash, and the challenges range. Sometimes it's who can solve it the fastest. Sometimes it's who can solve it with the least amount of code, like the minimum number of bytes. Sometimes it's a reverse challenge where you can only see the output and you have to write the program that would give that output. It gets pretty interesting. All right, we're full. It's going to start soon. Can we fold? I don't know. Let's go. Okay, you have to pass the maximum number of tests as fast as possible. Okay, so as fast as possible, you need to solve this problem. And for anyone else that joined, you don't have to use JavaScript. You can use any other language, but I am going to use JavaScript. So let's read the problem. It says, when you go to dinner with your friends, everyone toasts with everyone else once. You wonder how often one glass bumps into another. An integer n indicates the number of guests. The output is the number of times the glasses have been knocked together. Oh, wow. So this is like a simple math problem, right? Um, is it n to the n power? So you can run your test cases. Lowercase n. This is like combinatorics. Okay, so we get the number. Oh, I see. So it's the number of glasses. If there are two, too hard, I quit. If there are two glasses, they're only going to hit together once. Okay. It's not going to be n divided by 2. That will work for like the simplest case, right? But with 5 friends, we're expecting 10. Oh, Connect 4 is broken? Let's see what's going on with that. I mean, I'm the timer's running. It's YouTube's turn. I think that's why. YouTube, it's your turn on Connect 4. How can we calculate that? I mean, I guess we could create an array with the number of people. Yeah, brute force it. So the array with the number of people, 2 to the n minus 2. 2 raised to the n minus 2. Let's try it. So for the simplest case, that breaks because we get back 2 instead of 1. N divided by 2? No. 2 raised to what power is going to give us 1? 2 raised to the 0th power, right? This is hard. What do I do? How can I even calculate this? Something involving 1/2 of n times n plus 1. Right. N raised to n. Well, no, that's still going to give us 2, right? Yeah. Hello, WebTech. If it's only one glass, then it's just n minus 1. Right. Okay. But okay, let's think about it. Let's stop panicking and think about this. So, let's say there are 3 glasses. This one to this one, this one to this one, and this one to this one. So that's 1, 2, 2. Is it just n minus 1? Can't be. No, because if there's 5, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. With 5 friends, what's the result supposed to be? It's supposed to be 10. Okay. Number minus 1, then subtract 1 from the number until the number equals 1. You should know this, Bob, if you're taking statistics. Well, this is more of like combinatorics, right? Can't see the problem. Okay, Doc has it. So 1/2. Is this fair? 1/2 of n times n minus 1. Can you let us know, like, what is this formula, Doc? Because that's probably going to do it. How do I submit? Am I too far? Oh, I'm too far zoomed out. Okay, so this is technically the formula, but we've cheated because Doc has given us the answer. Oh, hello, Mole. Yep, you can't speed it up. It's real time. N minus 1 factorial. Choose n2. Simplifies to Doc's formula. Okay, so how would we calculate n2? Is it a factorial? Because I can write the code for a factorial. Just got n choose 2. So what is there a choose algorithm? Yeah, calculate the value of n choose k. Use the multiplicative formula. What a great way to start a stream, right? I have no idea what I'm doing. And I guess that formula simplifies to what Doc sent us. Hello, terminal. Welcome. Euler's summation. Number of 5 clinks equals 4 plus 3 plus 2 plus 1. Oh, okay. Let's just calculate that. I can do that. I guess I can't. It's hard to like being able to even view this thing. So, total starts off as 0. No, total can start off as in. And then while in is greater than 0, we're going to say total plus equals in. So we'll start off total at 0. No. Yeah, total starts off at 0, and we start at n minus 1. Has everybody else has gotten it? Okay, not everyone. So we start in at 4, and then we do 4. So that's going to give us 4, and then we say n minus equals 1. 3, 2, 1. Okay, and then we should log total. Assignment to a constant variable. These should both be lets. Okay, works for that. Works for 5. All right, I think we've done it. That was easy enough. Cool. All right, submit that. Thank you, Doc, for the formula. Basically, you take the number, subtract 1, and then add every number below that to itself. Is that in factorial, though? Factorial is multiplication, isn't it? This was addition? Oh, we have a formula. Let's see if we can see it over here. Let's take a look. It's hard to see. I can't see that. It's very hard to see. And if anyone has finished, make sure you click share your code so we can take a look at it. N minus 1 factorial. Math. Yeah. Hello, the real Python. Standard 1/2 n times n plus 1, but with n minus 1 instead. Yeah, so it's not a factorial because it's addition. I mean, sorry, yeah, addition. But it's similar because the numbers do go down. Hello, Ghost. Welcome. The sum of n minus 1 plus n minus 2. Yeah, that's what we did. YouTube, have you played Connect 4? Oh, yeah, you have. Okay. But it's your turn again, YouTube. I'll play. We're going to go in column 0. We're going to win. Did that work? Is that how that works? Yeah, there we go. N factorial divided by r factorial times n minus r is the combination formula. I clicked share my code. Amal says Lisp is the worst language there is. Cool. All right. Let's see how Alka did it. And so this is the brute force method. We have a for loop that goes from 0 all the way up to n, and then we have a nested for loop that goes from the current value plus 1 all the way up to n. So that was what I was doing with my fingers, like this to this, this to this, this to this, this to this. Now that one's done. Then this to this, this to this, this to this. That one's done. This to this and this to this. That one's done. This to this. That's what this for loop is doing. It's putting fingers together. And this is kind of like the brute force method. Great work, Alka. NerdCan did it with Python. Let's see what you got. Oh, interesting. We're going to take the min of n and r. What are we calling NCR with? The input is n. We're calling NCR with n and 2. So this is the choose formula. So n choose 2. And we're taking the min of initially is going to be 2 and n minus 2. Then we reduce over the range, and we're multiplying that becomes the numerator, and then we reduce over a different range, that becomes the denominator, and then we divide. Interesting. So this is solving some other formula. That's pretty cool, though. Does anyone else want to share their solution? You can click share code on Coding Game. Euclidean ace. N times n minus 1 minus 2. That's the formula that Doc gave us. Cool. I'll wait a minute or two more for anyone else to submit. Vuthon or Sesgo? Or no, Vuthon did it with C. It'd be interesting to see the... oh, NerdCan is you. Okay. You did it in Python. But it'd be interesting to see the C solution, so share your code if you'd like to. Oh, and this was... Oh, wow, this was Lua. I didn't even notice. But looks pretty readable coming from a JavaScript developer's perspective. The NCR formula from Stack Overflow. Cool. Yeah. Hello, David. Hello, Waihu. Hello, Andrew. That's a cool emote. What is that? Lua and JavaScript are surprisingly similar. That's good to know. I've heard of... Isn't there, like, Lua script? And thanks for the follow, TechCanna. The choose formula did work, because Merit Chan used it. Balloons. I guess this is fun. This stream could turn into a coding game stream instead of a code Katas stream. I want to do another clash though. We'll leave the actually I'll do this. I'm gonna leave this clash running, and then we'll start another one for anybody else that wants to join. And if you got to join this one, maybe wait like a minute before you join this next one, so that you give people other people a chance to join. Let's do another one. That was hard. I don't like it when it's like a very mathy problem and I'm not familiar. We could have figured it out. I don't know, but there we go. Let's do it again. If it's not a mathy problem, I'll actually solve it. So embarrassed. You need an account on this website. So I just shared the link to this particular clash. So I think you can sign in with GitHub and then you can join the clash. Okay, you use that formula. Nice. Math always works. Yeah, let's try it. Let me know if you make it, Kood. Yeah. Math is hard. I mean, technically, we could have solved it the way Alka solved it, which is just like a nested for loop. It's not that mathy. But it made me think of like combinations and stuff like that, which is very math. In 3, 2, 1. Here we go. Okay, fastest mode. You have to pass the maximum number of tests as fast as possible. Let's go. Print OK if the super long integer n is not divisible by 4. Print otherwise. I think the issue here is that, oh my goodness, it's a really long number, so we can't store it in JavaScript. Right? We're just gonna say if in mod 4 is equal to 0, then we're going to log OK. Else we're going to log that. Will this work though? I think this is going to break for very large numbers. Oh, did I get it wrong? Print OK if is not divisible by 4. So we'll flip that. So if in mod 4 is not equal to 0. Oh, okay. They didn't give us huge numbers. So it wasn't that bad. I thought we were gonna have to do. I thought we were gonna literally have to do division manually with basically like a shift register, so you can hold a really big number, and we didn't have to do that. So that's a good thing. We'll do one more after this. If the last 2 digits are divisible by 4, the whole thing is. That's good. That would have been good to know. But apparently it worked. So yeah, I think it's 12 users in total for a clash. Hello, Hygor. Welcome. Hello, Mr. Evergreen. And thank you, Bayandaglir. All right, let's see what NerdCan did in Python. Same thing. So this is fun to see the different languages, but if oh, they did that. Yeah, so we got some mathy people watching, but I'm guessing that this takes the last 2 digits of in. This is kind of like a slice in JavaScript, but it's going to take the last 2 digits of the number, see if it's divisible by 4, and do the logging. Very cool. Oh, no worries. I'm going to do at least one more of these, so you'll have a chance to join. All right, let's see what Alka did. Same thing. If in, oh no, opposite though. So if in mod 4 is equal to 0, log otherwise log okay. And oh, they also did that. They only chose the last 2 digits of the number. Apparently it worked. You didn't have to do that, but it's good to know that that's a math rule. If a number's last 2 digits are divisible by 4, the whole number is divisible by 4. All right, let's see what Angelo Solarito has. I follow the rules. Oh, is this Python? Answer equals okay if in mod 4 does not equal 0 else. The thing is, so this is Python. It looks like a ternary, but I think this is just an if else without like new lines or white spaces, right? That's super interesting. I didn't know you can do that in Python. Very cool. Who else? Vutan, what do you got? Oh, it's in C. Very cool. Python's way of doing a ternary. That's cool. So in C, we're going to read in the number, and then we just can do a ternary, very similar to JavaScript. So if it's divisible by 4, otherwise, okay. Very cool. Happy phone, what do you got? Oh, C++. Wait. How is this an answer? You're just outputting 100000000, and you got it right. Oh, I see. You have a 0% score. Okay, so you can submit anything. It doesn't have to be right. Cool. Anyone else? Oh, here's. Did I see Dan? Oh, cool. If in mod 4 is greater than 0, okay. Otherwise, There's so many different ways to do this. So you can flip the ternary. You can do greater than instead of equal to. All right, what do you got, Alex? This is in C++. Very similar. And it's also interesting to note that like you could store the result in a variable and then log the variable out, or in something like C++, this is kind of like having an inline console log. So if in mod 4 is not equal to 0, then just console log okay, otherwise console log All right, let's look at the last clash and see if anybody else submitted. I don't think so. Okay, let's do one more. To join, you have to use the Respondus lockdown browser. What is that? Here, and I'll give everyone a quick second to sign up on the site. If you haven't yet, just go there and log in with GitHub. And then when I create the challenge, you will be able to just join it. Oh, close all other application, no new tabs. Private clash. Here we go. I wonder if the giant number is actually being input and converted to a float in the case of JavaScript, and it just happens to still work. Yeah, or it could be that the number somehow has the last correct digits whenever it loses precision when it becomes a float. I don't really know. Monitor participants with a webcam. We're not like proctoring a test or something like that. All right, get ready. Here we go. Fastest mode. So you have to pass the maximum number of tests as fast as possible. I want to get like a code golf one, but let's see. Okay. Your program must compute the value of a linear function at the given points. A linear function is of the form a times x plus b, with a and b two constant values. You are given the values a and b and a set of n values of x. You must compute the value of f of x for each of the n values of x. What the heck? Okay. So they give us a and b already read in, and then we get the value n. Math. We're iterating from I equals 0 all the way up to n, and then we're getting x, which I guess is going to be each value of x. Oh, easy enough. I think that's easy enough. We literally just need to compute a times x plus b. And you just log multiple times. Yeah, I think that's easy enough. So you literally can just do a times x plus b. Oh. Are we logging every possible value? Do we need to like build up a string of new lines? I think that's it. Yeah, not so hard. That was all you had to do. A times x plus b, I think. Nerdcan, share your code. Yeah, literally just do a times x plus b and log out every time. Hello, Diego. I'm doing good in quarantine. Just staying home, cooking all my meals. It's good. Yeah, I'm actually used to being home a lot, so it's not really that different for me. The only difference is that I'm not ordering takeout every single day. I've only ordered takeout like once in the past few weeks. Yeah. Done. All right, let's see what Nerdcan did in Python. Similar thing, just print a times x plus b. Cool. I'm curious, was all of this given to you already? Yeah, it was very anticlimactic for that long description. I agree. All right, what do you got, Euclidean? Or no nickname is next. Did it in Java. Interesting. So read in all the numbers. Read in x, calculate the result, output the result. Yeah, it gave you everything, basically. Let's do one more. That was too easy. I want either a reverse one or a code golf one. So they have ones where you have to have the smallest solution to actually win. It's not about the fastest code, it's about the smallest number of bytes. Yeah, Dan Garden did exactly the same thing as me, just log a times x plus b. All right, this is done in C. Similar thing. The major differences between the languages is really just how do you read in input from the console. Happy Phones got it. Ah! Yes, so apparently you can put anything you want. So we take the string we split it, and then for each we log hello CJ LOL 50 times. That's a lot of logs. Let's see. Ventesi did it in C. Very similar. Cool. All right. Let's do another one. Only because these are like so anticlimactic. Right? That's a good word for them, isn't it? LeetCode started a challenge. That's cool. Oh, that's good, Diego. Hopefully I speak clear enough. A lot of people say that I speak English really fast, so it can be harder to understand for non-native speakers. But yeah. Clash of Code. Private Clash. All right, here we go. One more. Hopefully it's a good one. I wish you could choose the challenge, though, honestly. And I don't think you can. It's just totally random. 3 more spots. All right, here we go. This, I haven't looked at it, but the Connect 4 game looks pretty interesting. All right, shortest mode. Okay, so you have to pass the maximum number of tests with the lowest code size. So you can take as long as you want to solve it, but your final solution needs to be as small as possible. And absolutely, yeah, so if you delete the comments, it's going to be a whole lot smaller. And I think it shows you, yeah, down at the bottom, you can see your code size. So right now it's 339, but if I get rid of these comments, it's down to 127. So those of you that are solving it, you want to do it in the least number of characters. Okay. And hello, Whale Boy. Coding game is, they have different coding challenges, but particularly right now we're competing. So there's 11 other people that are competing with us to solve it with the shortest amount of code. All right. So the program must print the first numbers of an arithmetic sequence of common difference r and start it by 0. An arithmetic sequence is a sequence of numbers such that the next term can be computed by adding a constant value r. Okay. The first integers of the arithmetic sequence of a common difference r starting with 0. So input is 5 and 2. 0, 2, 4, 6, 8. Okay, this is a little weird, but I think what you need to do is the first number you're given in is how many in the sequence you need to go up to. So we're gonna write it out in long form. We're gonna write it in long form first, and then we can shorten it down. But if I just have a for loop where I get set to 0 while I is less than in. So in this case, in is 5 so we're gonna go from 0 to 5, or sorry, 0 to 4. I plus plus. There we go. So we go up to that. And right now I'm just gonna log. Well, actually, I guess we need a variable. Start equals 0. We're going to log. Well, let's call it current. So we start off at 0. We're then just going to log current, and then we say current plus equals r. So we increase the current value by r in this case, which is going to be 2, and then it's going to log each thing out. Let's see if this works. It might break because I'm logging each thing on a new line. Yeah, so right now I'm logging each one on a new line. Technically, we need to do it on a single line. Yeah, so Unhot is saying it. Don't you want to output a space-separated string of integers? Yes. So instead of logging each one, I need to essentially build up a string with all of the values inside of it. So let's say all. We're just going to make that a string. And then we'll say all plus equals current plus a space. Like that. So that should put a space on each one. And then we're just going to log all. That's probably going to have an extra space on the end. Wait, what? Expected nothing. Same thing. But it's because I have an extra space. So we're just going to trim that last space. Yeah, so that works. I think we've done it. Yeah, cool. Now our goal is to make this as small as possible. And you can see the problem description was a little tricky. But basically all we have to do is go from 0 to n, and we have a value that starts at 0 and increments by r in times. So that's what we just coded up. And hello, Kyle Smith. Yes, we have to solve this with less code. Though I've seen before that like a for loop actually has less characters potentially than a reduce. But let's see how we do it. So first of all, I am going to change all of my variable names. And we are going to use var because that has less characters than const. So there's that. And then, yeah, let's just use var all the time. I guess we could technically use let. Let has the same number of characters as var. And then, so you'll notice that inputs is an array. We could technically destructure it, and that's going to give us less code. So I could do something like this. We get n and r. We're not parsing it as an integer, but we could do that right here. We could just add a plus sign, and that makes it an integer whenever we're using the value. So let's see if this works. Yeah, so all the test cases still work, and our code size is now 171. Declare all with, oh, I guess, you know what? We actually don't even need, we don't even need let. We can literally just do this, I'm pretty sure, because it's not in strict mode. So we can remove all, yeah, look at that. We don't need var, let, or const. And, oh yeah, and we can get rid of spaces. So we can do this and get rid of spaces. Use for each for less characters. We'll see if it takes less. But what I'm going to do right now is remove all the spaces that I can. So you don't need to have spaces between the equal sign. You don't need spaces between the parentheses. You don't need spaces here. I'm not going to put it all on the same line just yet, just so it stays fairly readable. Remove the semicolons, good point, because in JavaScript you don't need them. Though technically, if we put it all on one line, it should be less code, and then we won't have semicolons. We'll try it. We'll try it with and without semicolons. I think their tests are just broken, Mikey. That's because the same thing was happening with Alka, but I think my issue was I had a space on the end, and I just fixed that with trim, like that. Yeah, short variable name. So let's call A. Can we do command? No, we cannot do command. Let's call A. All is just going to be the letter A. That works. We're going to rename current to be C. JavaScript. Looks like that works too. Each round is the counter times R. Oh, so I don't even need current? Is this what you're saying? Will this still work? Oh, look at that. Thank you, Acid Spark. So apparently we didn't need that C variable. So we're gonna get rid of that, and now we can just do that. Are there any repeated functions like an alias? Not quite. So look at this. Our code size right now is 95. I'm gonna hold on to that, and I'm gonna see what happens if we remove semicolon. Well, actually, let's do this. If we put it all on the same line, like this. We have 86. Our code size is 86. Okay, but let's see what happens. We're gonna go back. We're gonna go back here. Yeah, comments do count, so you have to remove those. Let's see. Oh yeah, you don't even need the curly braces on the for loop. Good point. Thank you, Ventesi. Like that. Yep. And technically we just put it on the same line. So that makes it 92? 86. Okay. So let's see how many characters it's going to be if we do like a reduce or something like that. Something seems wrong with the internet in Europe. That's not good. And hello, Dirk Diggler. And thanks for the follow, Wellboy. Oh yeah, good point. Well, so we do need to turn it into an array, but this is technically splitting on a space. So we can't really just spread it into an array, because it would have spaces in it, I believe. because this is our input, like 5 space 2. I think. I'm frozen? What? Really? Is that true? And thanks for the follow, Turk Tigler. Anyone else, let me know. Am I actually frozen? Seems okay? All right. Okay, so we can absolutely do this with a reduce. I think, who was it that mentioned that earlier? Kyle Smith. Kyle Smith mentioned that we could do this with a reduce. And thanks for the follow, Papa D. Or, yeah, Papa D. We have 4 minutes left. I think we had 15 minutes in total. And thanks for the follow, the real hottest Cheeto ever. Thanks for the follow, Lika. Okay, yeah, let's do this with a, I guess we can't really do a reduce, because we'd have to create an array first. But we could do, like, array of length in, fill it with, well, no. We could do array.from. Pass in length is in. And then we get this function here that's going to give us access to the value and the index. The index is what we need. And then we do this with the index. Like that. Yeah, so that works. And if we remove all the spaces, and we write it all on the same line. Oh, and we can get rid of that space too. This is 98 characters. So the for loop is technically smaller. Does anyone have any better ideas about how we might do this with like a reduce or something like that? I times equals plus R. No? Maybe? Let's see who has the short. Yeah, so NerdCan has 81 with Python. I think I would be okay with 86 in JavaScript. Can I chain the dot join at the end of the array instead of doing it by hand and then trimming? Oh. Yeah, let's try that. So instead of stringing together that, here's what we're going to return. Oh, no, we can just return this value. Like that. And then that gives us back an array, and then we join it on a space. Yeah, I think that's what... And then we can put all of this in a console.log. I think that's what Merchan was saying. So this gives us 86 characters. Does it work? Yes. Nice. Trim within the for loop. Would that be less code though? So, all right, how long do we have left? We have a minute left. Let's see if we can make the for loop smaller by... Oh yeah, there's a space after length. 85? I think that's as good as we're gonna get. We only have a minute left. We're gonna be like in second place. We'll submit it. Did I remove that space? Are there any other spaces I can remove? Oh yeah, remove the last semicolon. There we go. That gives us 84. I think that's it. Submit. All right, we got second place. And I'll share my code. All right, that was a fun one. Team for loop. Wait, which one did I submit? Did I submit? No, I didn't submit the for loop. I did array.from. So this is interesting because you can pass in an array-like object, and then it gives you a callback function, which will be called on each element, and whatever is returned will show up in the resulting array. And so ultimately that underscore is going to be undefined because every value in the array doesn't exist because this is just an object with a length property, but I is the actual index, so we can use that to compute the actual value. Cool. Yeah, and let's open the first place one. That's NerdCan, who got, oh, Alka got it in 81 characters. All right, yeah, we'll do one more. This is fun. Yeah, and let's look at the first place, who did it in Python instead of JavaScript. Oh, in R equals int I for I and input dot split. Interesting. So this is a way of, like, this is taking in the input to set in an R, but that's some weird code to do that. But then we're going to join all of the elements, all of the indices times R in the range from I to N. Python's weird. Python's not weird, but this has more mental load, I think, than JavaScript to try and understand what this is actually doing. What are these called in Python? Like a list. What's it called? It's a thing with where you're doing a. It's definitely a. This is, I guess, a lambda. Yeah, list comprehension. There you go. Thank you, Mihai. This is a list comprehension. All right, let's see how Alka did it. They did it with the for loop. Okay, so we could have simplified our for loop, which would have made it shorter. But yeah, we did the destructuring. I equals 0. Oh, and you can. This probably saves some space by declaring your string variable inside of the for loop instead of outside. And then add the space, trim it. Very cool. Great work. No worries, the real Python. If you paste your code in the chat, at least what you wrote, we'll take a look at it. List comprehensions are weird at first, but super useful once you get used to them. Yeah, it kind of feels like reduce in JavaScript, but the syntax is a little different. Yeah, interesting. It can absolutely be more readable. Okay, I believe it. The drop game is just HTML. It doesn't use Canvas. If you search on my YouTube channel, there's a live stream where I actually built the drop game. Yeah, no worries. We'll do one more. We're going to do one more. Did it get auto-modded? Oh, I see. You shared it on here. Cool. All right, did I miss anything else? Thanks for the follow, vflag. And oh yeah, we're gonna look at more. Let's look at I am not good. Destructure that. We have a for loop. This is very similar to like my initial solution. Very cool. Euclidean ace did it in Lua. String.match io.read. And then we have is this a regular expression? Huh. So this is cool. So they've reassigned. So I'm guessing toNumber is built into Lua, and they've reassigned it to the variable im, so that reduces the number of characters, so they can reuse it. Like technically, we're saying toNumber. And in apparently is the string.gmatch becomes a function? Oh, maybe each time you invoke it, you get the next value? That's super weird. Yeah, is that, let me know if that's what's happening here. So like this string.gmatch gives you back a function when invoked, gives you the next value. It's kind of like a generator or something from io.read. That's weird. But then we have in that starts off as -1, easy enough, and r, which is just the second value. We have a for loop from I equals 0 all the way up to n. Yeah, so string.gmatch returns an iterator that returns each match of the pattern. That's really cool. It's like a generator function for the input that it was reading from. And then we're going to write I times r if I is less than end and a space, or nothing. Oh, that's cool. So it's kind of like I guess you're doing a ternary to determine if you need a space or no space. So if it's the last value, no space. But if it's not, but if it isn't the last value, put a space. To put a spaces between the items. Huh. Lua's cool. I like it. Oh, hello, Mint. Welcome. And thanks for the follow, Running Van. Oh, happy birthday, Nick Gurr. Hope you're doing well. Hopefully you got some cake while you're staying at home. You love the drop game better. Are these games winnable using a statically typed language? On coding game, you can use Java, you can use probably C#, C++, C. Yeah. Yeah. And thanks for the follow, Omar. Hello, Nick Greer. How many are watching? There. It says, at least my dashboard says there's 77 on Twitch. Oh no! What did I do? What did I do? What do you mean, oh no? That's okay. No, it's fine. That's not what it was. Nick is probably a great person. It's their birthday. I hope that they got cake. That's all. Nick Greer. That's his name. And hello, Vintesi. I don't really have a stream schedule. Wednesday is usually Code Katas. Right now we're doing coding game instead of Code Katas. But it didn't. I don't think it happened last week. It's very sporadic. It probably was, but we can't feed the trolls. If you acknowledge the trolls, then they just grow bigger. All right. Somebody said they did it in Kotlin. I'm curious. Yeah, Razor did it in Kotlin. Ooh, so Kotlin. I've never actually looked at Kotlin before, but I know that it's what replaced Java on Android, right? And this looks, yeah, you're importing Java util in Kotlin? That's crazy. We have a function that takes in a string array, a scanner. Yeah, I mean, this just looks like Java, right? Isn't this just Java? I don't know, but it's all on one line, so that's cool. Kotlin equals Java. I thought it was a new language. I don't know what's new about it, but we're just doing a for loop from 0 up to n. Well, it looks like we have this looks similar to like template literals in JavaScript, a way of like having an expression inside of a string. Kotlin is Java with extra steps. Oh, and hello, Andrew. Yeah, I've been live for about an hour, but we're getting going. Drop last one. Interesting. So this is like a trim. Get rid of the last character on it. Cool. Great work, Razor One. All right. Did we already look at Alka's code? Yeah, we looked at Alka's. Client telephone. What do you got? Let in equal parse int. Okay, yeah. So we just have a basic for loop, and it looks like Twitch just won the Connect 4 game. So great work, Twitch. Well, we have a for loop from 0 up to n. R is our string variable. Very cool. Very cool. Here's Dan Garden. Let's see what you got. 276 characters. Okay, O equals an array. J equals read line. Split it on spaces. Map it. Parse it. And R equals a negative J at the first index. Interesting, but I see what's happening here. Instead of using a string to build up the values, we're using an array, and then at the end we just join the array on spaces. Very interesting. I'm curious, why is this negative though? Plus equals? Yeah, I don't know. Hey, Splart, how's it going? I have not seen Happy Phones drop emote. Should I look at it? Is it a bad thing? Is it a good thing? No, it's really cool. Okay. Drop. All right, and let's. Oh, the real Python was using PHP. That's fun. So we can read our variables in. We have, I guess, $O is our iterator? No. $I is. While I echo that plus equal the value. Cool. What is this? Wait, did I miss it? I think I missed it. No worries. It's cool to see Python though. I don't really work with Python. So like variables have $signs on them. It's cool. I missed it? Okay. I'm gonna have to wait 90 seconds to see it again. PHP. Did I say Python? I meant PHP. I meant PHP. I know that was not Python. All right, let's do one more. All right, somebody tell me when oh, did I miss the C solution? Oh, Happy Phone. Oh, wow. Great work. That's awesome. Good job. It's who did it in C? We can't see their code. All right. Let's try one more. And then I think I'll spend, I don't know, an hour, 45 minutes on that 1Q problem from a while back. Here we go. Everybody's doing it. Do I have a video about JWT refresh tokens? I do not. I could talk about it in the future for sure. Every time someone mentions that, I always direct them to bin awad. Oh, well, I gotta start coding. Okay, this is fastest mode, so the first person to finish gets the points. But check out bin awad on YouTube. He has really good JWT stuff. Okay. The program. You have intercepted an enemy communication signal, but it is encrypted. However, you know that the message was encrypted using the following algorithm. And thanks for the follow, Sir Stoner. For every letter in the message M, an integer E representing the distance away from the letter Z in the English alphabet is outputted onto a new line. Spaces are given a value of -1. And you must decrypt this communication. Okay, so it's like a shift of the letters. So you have M. E is the distance away from Z. Okay. So we have first is how many we're going to get. 1, 2, 3. Yeah, so if the first input is the number we're going to get, and then each one after that is the actual value. So 18 results in H. And so 18 away from Z. So what I want to do is just get the char code for Z. Which is 122. And if I do 122 minus 18, that gives us 104. And if I say string.from charcode 104, that gives us H. So this is basically what we have to do. We're going to do 122 minus that value and pass it into string.from charcode. So here we go. We're going to need our message equals the empty string. And then we'll say message plus equals string.charcode at 122 minus E. And that's going to give us our whole message. And then we can log the message. All right, what do we got? It works. Oh, it broke. So, it looks like if it's a space, how do we detect if it's a space? Spaces are given a value of -1. Okay. So if E is equal to -1, message plus equals a space. Else, message plus equal that. This isn't code golf. I should have written it out on multiple lines, but I want to be fast. All right, I was the fourth one to complete. I'll share my code. The game had already started, so you can't join afterwards. Oh, and thank you, Sir Stoner. Yeah. Thanks for coming over to the Twitch side. And hello, Samir. All right, let's see what Draken has done in Python. Yeah, couldn't get out of the code golf mentality. So, if E is -1, we're going to print a space. Otherwise, we're going to print... Okay, so ORD is built into Python, so the ordinance of Z minus E and get the character from that. So apparently this is a way of like getting the character code for Z, subtracting E, and then getting the character that represents that resulting character code. Similar to how we were doing it in JavaScript. Cool. Yeah. What's up, Beerus? Welcome. All right, let's look at what NerdCan did. Yeah, similar thing. So ord, let's look these up. Python ord function. I'm guessing it's the ordinance? I just want to see like Python reference. 5 examples of the Python ord and chur functions. Yeah, so it gets the code point. It's probably not ordinance. Yeah, I don't know, but cool. Very cool. All right, let's see what Euclidean did it in Lua. So we can say string.byte. Apparently that gives us the character code. And then string.char, you can pass in a character code and get back the resulting character. Pretty sweet. Angela Solitario. They used Python, but they did something different. So similarly, 122 is the code point for Z, and then they just use char. So instead of using ord, they just use the actual value, which makes total sense. That's what I did in my code. Let's see what unhot got. Similar thing. So we have a Z value stored with the ordinance of Z. Instead of calculating it every time, we just put it in a variable. Very cool. And thanks for the follow, Celesrina. And what's up, Nate? How's it going? The name of the program I use for monitoring temperature. Oh, this up here. This is known as iStat menus. It's a Mac thing. This thing. I think I have iStat menus 5. Basically, every time they come up with a new version, you have to buy the new license. And I bought the license for version 5. So I haven't upgraded yet because it costs money. But you can control all these different widgets up at the top. Hello, Kevin. Welcome. Oh, nice, Dylan. Glad you could make it. All right, what else? No nickname. Did it with Java. So Java, it looks like we're doing not really even casting. So we're saying literally a character minus the value of E, which is an integer. And we're casting that to a character. So in JavaScript, I would think like this would seem like it's doing coercion, but I don't think that's what's happening here. I think that characters in Java actually have an integer value. Like you can cast a character to an integer and get back the code point. I think that's what's happening here. And so ultimately we get the overall code point and cast that back to a character using that code point. Very interesting. Yeah, in C and C++, it's the same. It's their ASCII code. Okay. Chars are simply a type of integer, or chars. Interesting. Danny Fritz! Share your code, Danny Fritz. If you click share code, we can see what you wrote. Oh, and did we look at this one? This one's C#? No, we didn't look at this one yet. They did a very similar thing. C# and Java are like so similar. But you subtract an integer from a char, which results in an integer, and then you cast that integer back to a char. Very cool. There it is. Oh. So we have a map of all possible characters. A is 25. C# is how Java should have been. I agree. And C# has gotten a lot of newer and better features that Java never got or hasn't gotten, or has taken a long time to get. Yeah, this is great, Danny. So instead of calculating the thing based on character codes, this is literally just a lookup of all possible characters. So we even, we could have calculated this, but we knew from the first example that 18 was H, 21 was E, 14 was L. So you can compute all of the possible conversions of number to value, and then just do a lookup. So for each number, do a lookup in that object to find the corresponding letter and append it to the answer. Very good. LOL, wrong. I guess Agent Key likes Java. Love Java, just dating C#. That's cool. All right. This is fun. We should do a Clash of Code show. Like, instead of code katas, it could be extra. We'll still do code katas, but Clash of Code is just fun, especially to see all the different languages and try to understand what's happening in those different languages. Yeah, +1. Languages. And so apparently the live stream is playing in this mod view. Yeah, that's me. Okay, I didn't know that. Let's do one more, because this is fun. And then I'm going to take a break, come back, and work on that 1Q kata. Java is the superior language. Okay. All right. One more. I'll give you a second. If you haven't signed up, go to codinggame.com. You can log in with GitHub. And then when I send this link, you will have... You have to be fairly quick because there's a lot of people watching. But once you click on the link, you'll be able to start competing with us. Are you ready? Here we go. And I will say, if you've already competed, wait like a minute. Try to give other people a chance. If not, that's okay. But try to give other people a chance to join too. Am I going to be able to get stream points soon? Oh, probably. I will enable, or I will sign up as a Twitch affiliate eventually, and once you're an affiliate, you can enable like channel points. But I'm not an affiliate yet, mainly because I'm cross-streaming on YouTube. Hello, Firebase Nuxt. I have never heard of the language J. I don't know if you can set the type. As far as I've seen, you can't. It's like random every time. But that would be fun to just do code golf kinds of things. All right, here we go. Oh, this is reverse mode. This is actually kind of hard. So what you have to do is guess what code to write based on the output and based on the tests that are provided. So the problem actually doesn't give you a problem statement. It just says, this is the input and this is the output. What do you do? What is 1440 divided by 12? 1200. What's 6 times 1200? 7200. 6 times 6,000. That's what it is. So you take the number, multiply it by 1,000, and multiply by itself. That's what we got to do. So we'll say, Cedric with the super chat, thank you so much. I will acknowledge it after I solve this. So take the number, multiply it times 1,000, multiplied by itself. Is that the answer? No. 6 times 1,000 is 6,000. 6,000 times 6. Oh no, it's 100, not 1,000. 100. Yeah, Bob got it. Oh, and everybody else has already solved it? Come on. Okay, I think we did it. Let's go. And I'm in last place. Or 11th place. Wow, that's the first time that happened. Cool. Raised to the power of 2. Add 2 zeros to the end. Oh, and yeah, the super chat from Cedric says, "What are you drinking?" I'm drinking a lime bubbly. It's a fizzy water. It's pretty good. It's losing its fizz though, because I opened it like 2 hours ago. And hello, Kevin, who says, "I'm starting to learn C++, and I already know JavaScript. Can I do a code force or leak code contest?" I haven't done those on stream before, but possibly. I think we looked at leak code once, and I wasn't really a fan of it. I have heard of this language. It's very interesting. Squared times 100. Console.log math.random run a sufficient number of times. Yes, that would work, technically. Hello, Storm, who says, "I'm working on my college senior project and using React, but I don't know how to fetch data from my Express server. When I use fetch, I run into a CORS error. Can you brief me on how to fetch data?" So if you're in control of the server, meaning you wrote the Express server and you can change the code, really all you need to do is add this CORS middleware to your backend code. So you can see an example here with Express. Just do npm install CORS, and then at the top of your Express app, like right after you create the app, say use CORS, and that's going to add the CORS headers so that your front end can make the request to your backend. That's mainly what you need to do. You could be running into other errors though, because if a route times out, meaning like it doesn't send the response in the right amount of time, that potentially can result in a CORS error as well, because the browser never gets the response, so it just says there are no access control allow origin headers. You could run into other issues like that. So for the most part, make sure you have this, and then try to debug and make sure that your response handler is actually running. Chewy. Next.js and Redux. I don't know about that. Oh, I saw somebody recommend this on the Discord, a Twitch extension that shows YouTube chats as well. Pretty soon, I'm only going to be streaming on Twitch, so I won't really need to do that. Things are going to get so much simpler when I start just streaming on Twitch instead of both. But yeah, all right, let's see what Draken did in Python. N times 100. There we go. Oh, I just enabled my break timer. I totally forgot earlier, but yeah, we haven't stretched yet. All right, we got Java that does n times 100. Very cool. We've got Python. I like this. That's what Danny Fritz recommended, I think. Take n squared, or into the second power, turn it into a string, and put 2 zeros on the end. I love it. It's much more original than just multiplying by 100. All right, we can see C#. N times 100. Very cool. C. Very similar. We're just doing the print formatting string thingy. C++. Very similar. Instead of doing a print, we're using cout. Though we reversed it 100 times n times n. But there's that property of multiplication where it doesn't matter the order that you do it in, you're always going to get the same answer. What's that called? It's a thing. Domenico did it in C. Very similar. And then I did it there. And Alka, share your code. It's probably very similar. Commutative. um, all right, Happy Phone, you enjoy the outside. I actually went outside and did jumping jacks today because I had been sitting and working all day. And so yeah, I did like 30 jumping jacks and I touched my toes. Yeah. What do I think about Lumen and Laravel? I haven't really used them. I've looked into Lumen. It seems interesting. Um, yeah. Yeah, access control allow origin is the header that needs to be set. The commutative property. All right, what did Alka do? Read line. Ooh, they made it as small as possible. Read line, raised to the second power times 100. Nice. Oh yeah, and I just like glossed over this, but in JavaScript, this is the exponentiation operator. They added it in was it ES 2015 or ES 2016? But you can do times, and that's the same thing as raising to a power of, which is pretty cool. Oh, nice, Storm. Glad to hear it. Jumping. No, I was not. Yeah. All right. I'm going to take a break, but when I come back, I am going to work on a kata that we, in the past, have spent a lot of time on. Episode 41. Is it 41? No. Episode 40. This was 2 episodes ago. The tiny 3-pass compiler. Here it is. Do a kata in Haskell. That could be interesting. I would do like a hello world in Haskell, but we need to get back into this tiny 3-pass compiler. So I think I can do that, right? Yeah. So I'm gonna share this. You all can take a look at it while I take probably like a 10-minute break, but we'll spend. I think we'll spend like 45 minutes on it. We'll spend 45 minutes just working towards the solution. It's very hard. It's a very hard problem. It is a 1Q. That's as hard as they get on Code Wars. And I went down a lot of different paths last time. Ultimately, what we settled on was to first convert the equation to reverse Polish notation. I think that's what we did. Because then we can build a tree from that. But basically, the problem is, given a string expression like this, we need to parse it and turn it into a program that can actually run. So it's a 3-pass compiler. We have to build an abstract syntax tree, and then we have to write something that will actually run the code that this compiles to. It's really tricky. There's a lot going on, but when I come back, we'll work on that. Do I recommend using Axios? If yes, why so? I would say yes. The main reason being is it's very standardized and that a lot of people use Axios. So most JavaScript apps you come across are going to be using Axios. And the thing about Axios is it has error handling built in. It has a promise-based API. It has all that stuff. You could use Fetch, which is just directly built into the browser, but you have to do your own error handling. And you have to do your own parsing. Like Axios will automatically parse the response based on the response headers, which is nice. You don't have to manually parse it to JSON or anything like that. So that's why I would recommend using Axios. You could find a fetch wrapper. Like I wrote one called Easy Fetch. Don't use this. I haven't looked at this in like 2 years. Look, I published it 2 years ago. But this adds extra things on top of Fetch that make it similar to Axios. So it automatically looks at the content type and does the correct types of parsing. It throws an error if the response isn't okay. All of these things you have to write yourself if you're just using Fetch. But you could find some other Fetch wrapper. Yeah, I remember this. Is there any way to install MongoDB on a 32-bit OS? I have no idea. You know, I think I thought about this like a month back because I did a workshop where I was teaching like basic full stack development, and we had to install, I wanted to install Mongo on all of the Windows machines, but then I realized some of them were 32-bit, so I don't really know. Yeah. Oh, apparently I'm pretty close to being done. Dark Hunter says, I'm demotivated. Some advice. Try to change things up. Rearrange your room. Clean your room, clean your house if it's dirty. Try to create a space that is inviting and that you actually want to be there. Rearranging will potentially allow you to take things from a different perspective. I don't know. When do I plan to continue the home inventory project? Probably in the next stream that I do. But I've had some ideas for some other streams that I want to do as well. The next step in that home inventory project is to seed the database. That may not be a whole episode though, because we'll like seed the database, and then we'd probably want to build an API on top of the database that we built so far. But I don't think we'd finish that in a single episode. Yeah. Oh yeah, I totally forgot about that. Watch that clip. I copied and pasted something from somewhere, and there was like some weird Unicode value or Unicode minus sign that wasn't the actual minus sign. I don't know. Oh wow, that's a good point, because isn't it open source? So you could compile Mongo on a 32-bit system, but it would take a very long time. Hello, JustWeb. Welcome. Hello, Glauco. All right. I'll share this one more time, but when I come back, we're going to revisit this problem. We're going to do our best. Doc says we're only 75%, or I mean, we are 75% of the way, so that's not bad. So we'll see. 8722? That could be on a Coding Garden t-shirt. Yeah. I think we'll use feathers. The reason being is like it could be so yes, this is like unrelated to all the things that we're talking about, but if you've watched those streams about the home inventory app, let me pull up the database diagram. This one. This. So loading? What? There we go. This is a very complex database with nested tables and join tables and relationships, and a lot of the tutorials and guides you see on Feathers.js are only working with like a single model. They're never really working with relationships, so it would be cool to show how could you build a Feathers.js service on top of a database like this with an ORM. I would probably use Objection.js, which is an ORM that will automatically join the tables and give you the nested data and stuff like that. But the question is, how do you structure that in a Feather service? And which one of these tables represents a Feather service, which one is not? So I think I will use Feathers because I'm just finishing up with an app at work we're launching, and I built it all with Feather, so I learned a ton about more complex application development with Feathers. Unhot says, I think I hate JavaScript, but you're so nice, I put up with it. Nice. JavaScript's not so bad. I don't know, I've learned to love it. It has its idiosyncrasies, but that's really why I like it, honestly. Hello, Depopam, welcome. Evan Bear, who's that? JustWeb says, I've been thinking on working on a project using Socket.io to get info from the Twitch pub sub server. I think there's pub sub server, you'd have to use like WebSockets directly. I haven't done this. I've seen other people trying to implement it. And if Alka is watching, maybe he can give you some advice. But I would think you would just use like the WS module, which is for WebSockets. There's other ones as well, but Socket.io adds some extra stuff on top. So that may be why you're having an issue, but I've never done that. I don't know. Yeah, Clash of Code is pretty cool. How much traffic do you think a Django application with Nginx running on 512 megabyte digital ocean server can handle? I don't really know. You'd have to load test it. It also depends on your application code and what it's doing behind the scenes. But yeah. Hello, Yixi. And thanks for the follow, Sentimin. No worries, aspect type. It's brutal. Yeah, I don't know. If Alka's around, Alka, paging Alka. Do you know anything about the what was it called? Yeah, the pub sub server, or setting it up with that. Idea for building a view counter. I don't know. And hello, Vishnu. All right, I'm gonna take a break. When I come back, we're going to work on this tiny 3-pass compiler. In the meantime, Coding Garden is brought to you by viewers like you. Big shout out to all of my patrons and YouTube members, and anyone that's donated or super chatted. But right now on the screen, you will see all of people that donate through Patreon and donate through YouTube memberships. Much, much appreciated. And there they are. I'll be back in 10 minutes. Oh, hello. Hello. I'm back. Hello, Pixa. I was on a break. That's what's happening. There's a lot of weird stuff on the screen. We'll let the patrons and YouTube members go by. The timer and stop button looks like an eye and a mouth. Yeah, I can see it. And thanks for the follow, Catholic Traditionalists. And yeah, Depapam on the leaderboard with a 93.01. Great work. That. All right. We're back. And it's time to address this problem, the tiny 3-pass compiler. So I'll share this link again. This is what I'm going to be attempting to solve. We have a partial solution. It is said that we're close to 75% of the way there. But let's get to it. So one thing I'm going to do is I'm going to copy our code from last time into the episode 42 folder, so we can see the difference between what I did last time and what updates we make this time. So let's do this. Let's copy recursively episode 40 / tiny 3-pass compiler into episode 42. Hopefully we don't break anything. All right, and if we go into episode 42, nice, we have a folder. And if we go in there, we have our node modules. Let's remove that report. I don't know what that is. And let's remove the node modules and reinstall them, because sometimes weird things happen if you move your node modules around. Hello, Jitesh. Okay, let's remind ourselves of what we've done so far. We were doing this in a test-driven way. And we were slowly building things up. But ultimately, we have this compiler. It has a compile function. It has 3 different passes. So you have pass 1, you pass the program in to compile it. You then pass that into pass 2, and then you pass it into pass 3. They provided the tokenize function, which basically takes the program in and splits it up into all the possible tokens. And then what we wrote last time was this tokens to RPN, so tokens to reversed Polish notation. So let's look up reverse Polish notation. So reverse Polish notation is a way of writing mathematical expressions so that they're easier to compute. Let's see. Can we see an example? And what Doc is mentioning is, last time, we finished implementing shunting yard to convert infix to postfix, and most of the time was taking up the... Okay, the original plan is to write a second function that then builds the AST, but what Doc is mentioning is they sent a message in Discord that describes how we can actually do it in one pass, so we can build the AST as we convert infix to postfix. And I'm not going to go over it here, but there's a really great video on, I think it's Computer File, on RPN and infix to postfix. This one, reverse Polish notation and the stack. So I'm not going to get into it, but watch this video because it has a really great explanation for like what RPN is, and then also why it's easier for computers to compute problems that are written in postfix versus infix. Okay, but the program we've written so far takes in a program. So the program might look something like, let's look at our tests to see what it might look like. Oh, you know what? I don't think we got that far. We didn't even implement this parsing the subtree thing. This was my initial try at it without converting it to reverse Polish notation first. Yeah. So really, where did I test this? Where did I test tokens to RPN? Here we go. Here's some tests down at the bottom. So basically what we're doing is we're taking a string that has some mathematical expression, and we're writing a program that can evaluate that mathematical expression by compiling that mathematical expression into a program. So what we did and what we implemented was we took this expression, 3 plus 4, and converted it to postfix. So this is infix because the operators are in the equation, and this is postfix because the operators are after the equation. So we've parsed some pretty complex what do you call it? Pretty complex equations and turn those into RPN. Great. And I'm about to pull up Doc's comment because he describes how we can build the tree while we or build up or convert it to RPN. Hello, Chirag. Welcome. I don't know if you can just give a Wi-Fi connection. Yeah, tokens to RPN technically works. We left off here. We were testing it with different inputs, but that one is done. Yeah, thank you, Merchan. It's called Just Black. It's pretty cool. Expressions. These are expressions. Cool. The next thing we do is we are going to look at Discord. We're going to look at the message that Doc sent that describes how we can go from, how we can build up the abstract syntax tree while we're parsing it or converting it. I use the Anonymous Pro font. Oh yeah, and so shunting yard is the algorithm that we implemented. Let's look that up really quick. The shunting yard algorithm. So this is a method for parsing mathematical expressions in infix and turning them into postfix or RPN. So that's the algorithm that we implemented. And this is what Doc has to say. It's possible to build the AST in one go with a small modification to shunting yard. Change the output queue to a stack. So if I look at my code, we have output queue is what we're using to create the postfix notation. So we change that to a stack. When a number or variable is encountered, push it to the output stack as normal, but now as an AST leaf node. So we can actually build up the abstract syntax tree as we go. And ultimately, what we're trying to generate, we can see here. So given a mathematical expression like this, we need to convert it into an abstract syntax tree that looks like this. So we're breaking things up into operations. So you have an operation with two operands, A and B, but the operands themselves can be operations that need to be performed as well. So A is actually an addition operation of these two. And in this case, A and B are just numbers. So this is 1 plus 3. That gives us the value of A. So that's 4. And then B is 2 plus 2. That's 4. Or 2 times 2. That's 4. And so we have 4 for A and 4 for B, and then we need the result, which is 4 plus 4, which gives us 8. And so this is an abstract syntax tree. This is a representation of this mathematical equation. 1 plus 3 is 4, plus 2 times 2, so that gives us 8. Right now, what we need to do is we need to take this reverse Polish notation and turn that into an abstract syntax tree. And what Doc is saying is we can do it all in one go. Instead of building the RPN first and then converting it, we can just do it all in one go. So I'm going to read his comment, see if we understand it. And if we don't understand it, we'll just try to convert it instead of doing it all in one go. And thanks for the follow, Harrison Pickering. Much appreciated. Elon Musk is giving away Wi-Fi. That's good. And hello, Elangel Nocturno from Argentina. Welcome to the show. Okay. When a number or variable is encountered, push it to the output stack as normal, but now it is an AST leaf node. So a leaf node is something like this, where it's not in actual operation, it's just a value itself. That's a leaf node. Whenever previously in the algorithm you pop operators off of the stack, if it's an operator, you also pop the 2 arguments off the output stack, right to left, and construct an AST node with those nodes as the children, and then push that back onto the output stack. Once the algorithm completes, the output stack will have a single item, which is the completed abstract syntax tree. Okay, I don't want to look at your code just yet. And then we have pass 2 and 3. Okay, so let's try to do it. we have our code backed up from last time, so it's okay if we like mess things. Actually, I'm gonna do this. So this is the tokens to RPM, and we're basically just going to modify this code, which instead of generating a reverse Polish notation, instead of generating postfix, we want to generate the abstract syntax tree. So really, this is just going to be pass 1. Like, I can comment out all of this code that I was trying. Actually, I'm just gonna delete it because we wrote this code last time. Parse subtree, get subtokens. This was my naive attempt at just doing it from scratch without trying to use any pre-existing algorithm. That didn't work out very well. Ultimately, we got it working for like very basic expressions, but once they got complex or once there were a lot of parentheses, it didn't work very well. So pass 1 is going to create the tokens. And then we're just going to return tokens to AST is what we're going to call this function. And this function should return an abstract syntax tree. I will need parse arguments. Oh. Was that? I wasn't using that before. Let's see. Or was I? Did I write this function? Did I write that or did it come built in? We're going to get rid of the tokens to RPN. Are we sure about that, Doc? I'm gonna look at the Code Wars problem because that might have parse arguments already built in. So they give us, oh no, we don't want C#. We want JavaScript. They give us tokenize, and that's it. Okay, we'll see. And thanks for the follow, T. Devore. Much appreciated. And thanks for the follow, Spring Pie. We're converting both x and 0 to strings. I don't know. I think we wrote parse arguments can't even tell what that function was doing, honestly. I don't think we need it, like, based on your write-up, right? That you sent? All right, I won't delete it, but for now, I don't think I don't think it's relevant to what we're trying to do. And thanks for the follow, GG Fallen Warrior. Much appreciated. Hello, Tony from Pittsburgh. Welcome. Code-R enables you to open another folder or file using the same window. Interesting. Okay. So we're going to do tokens to AST with the tokens. And really, we just need to return that. Okay. My databases are disgustingly complicated. Coding train crossover was nice. Oh, thank you. Much appreciated. All right. This is what was happening last time. I was just like procrastinating to not actually do it. Tokens to RPN will need to take the arguments list as a parameter. When you encounter a variable like X, you need to convert it to a numeric index by looking at... Oh! Okay. I see. Yeah. Okay, so I did the job of parsing. Okay. Easy enough. So if the program looks like this. This is our input. And this parses those to get back the variables. Okay. That makes sense. I guess, I wasn't really using it in RPN though. Oh, because we were just converting the expression. We weren't actually converting the, we were just converting the mathematical thing, not the actual input. Okay, very good. So parse arguments is actually gonna give us an object lookup of the args, right? We have args, that's an object. Okay. So are we determining where... Oh, we're returning I. Okay, so we know where tokens should start. Okay. Okay, this makes sense. I'm figuring this out. So this dot parse arguments with tokens, and that's going to give us back args, which is an object array where we can look up what our arguments are, like X, Y, and Z. And it's also going to give us back the index that it left off at. So we can do tokens.slice starting at I, and that should give us the rest of the tokens. And Kevin on the leaderboard with a 98.79. Great work. Yeah, that's what it does. Okay, we figured that out. I'm glad we can figure out the code that I already wrote before. And I think slice, we want to do I plus 1. So that token, if that token is equal to bracket, we're returning I. So I think we're going to do I plus 1. And then now our tokens to AST is going to get the args and the tokens. Thanks for the follow, Cackle. And hello, Mustafa. Hello, Tony Capone. We're working on a 1Q kata. It's called the Tiny 3-Pass Compiler. If you just Google Tiny 3-Pass Compiler, I'm sure you'll find it. Inside the shunting guard, I'll need to add additional logic to check whether the string is a number or variable. Yeah, that makes sense. Okay, so let's look back at your code here. People who didn't watch the last episode. Are you providing a link or what? The image did not load. What? What's happening here? That's a weird, a weird image. Previously on Code Wars with CJ. Okay, look at Doc's message. Change the output queue to a stack. Can I call it the output stack? When a number or variable is encountered, push it to the output stack as normal, but now it's an AST leaf node. Wait. So before it was a queue, and whenever we push into a queue, it's always going to put it at the end. But when we push into a stack, it needs to go on top, right? It needs to be the first thing, right? So instead of, if this is now a queue, tell me if this is right, Doc. Anytime we were pushing into the output queue, we should actually be putting it at the beginning or putting it on top of the stack. Is that accurate? So when a number or variable is encountered, push it to the output stack as normal. So if we're looking at the output queue, I suggest you stick to pop and push rather than shift and unshift, because otherwise it gets confusing. Well, my operator stack, I was using shift and unshift. But push is just going to put it onto the end of the array. And then I guess pop will remove the last one. So that could technically still work. All right, so let's call it the output stack. And we need to fix anywhere that wasn't using it before. So if it's not an operator and the token is not a parenthesis or a closing parenthesis, then that means we have a number, right? Because if it's not an operator or a parenthesis, it's either a variable or a number. So we're going to say output stack. That's a good point, Doc. When you do shift or unshift, it potentially has to shift all the values in memory, so it's big O of n. Okay, so we're going to push, not the token, we're going to push a leaf node. And a leaf node looks like this. We can see in the examples, the operation is IM for like immutable. And in is the token. And I believe, yeah, Doc was mentioning that we can check if it's NaN to see if it's like X, Y, or Z. Yeah. Look up argument. I'm trying to remember when and how do we actually look up arguments that get passed in. Because, like, this is the program, X, Y, and Z. So we don't actually have a value here. We just have a reference to X, Y, and Z, whatever those inputs are going to be. Oh, M means immediate. Thank you, Jitesh. So an immediate value, that is not like a lookup. Oh, the operation is arg. Here we go. That's what we want. So we can say if args at the given token, then we're going to say output stack dot push arg, and then in is going to be the token. No, args at token. And really, I'd probably need to do if token in args, because it could be 0, which is falsy. else it is an immediate value. I mean, we could do isNaN, but I believe the tokenization actually turns it into a number for us. So it's already parsed. And our arguments are going to come back like this, X, Y, and Z. Oh, no, never mind. That's right. Because this token could be like X, Y, or Z, and if that's in the args, then we say arg, and we say in is 0, 1, or 2, depending on where that argument came from. Otherwise, in is the value itself. Okay, we've done that so far. If I finally do this and all the tests pass, what will I do? I'll be excited. It's a 1Q. IsNaN is better because you can also detect undefined variable errors. Oh, that's a good point. So in the future, if they give us an expression with a variable that we haven't seen before, we need to throw an error of some kind. Okay, I'll do the isNaN thing. So if the token is not NaN, is that how isNaN works? Okay, which is different from number.isNaN. Because that looks explicitly for the NaN value. Okay, so if it's not NaN, that means it's a value, and we'll just put it there. Otherwise, look up the argument. Cool. I mean, technically, that's the lookup. Whenever we're... I guess if this comes back as undefined, when we're actually compiling it, we'll figure that out. But okay, regardless. When a number or variable is encountered, push it to the output stack as normal, but now it's an AST leaf node. Okay? Whenever previously in the algorithm you pop operators off the operator stack, if it's an operator, you also pop the 2 arguments off the output stack. So whenever in the algorithm you pop operators off the operator stack. So this is the operator stack. And if we do shift, is shifting popping off the stack? That's where it gets confusing. Array shift. That removes the first value in the array? Yeah. So the shift method removes the first element from an array and returns that removed element. So anytime we're doing operator stack dot shift, those 3 spots, if it's an operator, you also pop 2 arguments off the output stack, right to left. So it's popping. And construct an AS2 nodes with those as the children. So instead of just popping it and putting it into the output queue, which doesn't exist anymore, we pop it. So that's the operation. And then we can say A is the output stack dot pop, and B is the output stack dot pop. Because that's going to be the 2 operands. And then we can say output stack dot push, an operation where the op, is it just called op? Yeah, so we'll just call this op. Op A and B. Just like that. Let's take a quick stretch. Ooh. So we're taking that operator and we're applying it with the two operands that are currently in the output stack. And then we're adding that to the output stack so it can become like a nested tree, basically. So we can do that there. And then we also have to do that right here. Right? Right. Pushback operator to do this and replaced all the previous cases of output queue, which with calls to that function. Yeah, because I mean, I just copy and pasted that code. But we could put this in a reusable function. Let's call it push operation. Like that. Do it again right there, I believe. If the operator stack is equal to a parenthesis, we just throw it off. And that doesn't, that isn't an operation because it's just a parenthesis, right? Oh, I have to implement that. That's why they're not rendered, because I haven't implemented them yet. Yeah, and Devilpam is saying that I inspired them to do Code Wars. That's great. A and B are reversed. Oh, right, because you're going to get B, then A. So it should be B and A, like that. Because you get B first. Makes sense. Thank you, both of you, Jitesh and Doc. If outstack is less than 2, B equals pop, A equals pop, outstack.push. Yeah, so that's what I've done. I'm not throwing an error. I guess potentially they're going to give us problems later on that, or expressions later on that could throw an error. Is that in the problem description to throw an error like that? Let's see. I'm just going to add a comment. To do error checking. And similarly, right here, whenever we're getting an argument, the argument could not exist. So error checking there as well. And thanks for the follow, Inceptions. Hello, programming. All inputs will be valid. Okay. I just like throwing reasonable errors makes debugging easier. That's true. I probably won't participate in Google Code Jam. I mean, at least I hadn't planned on it. I don't really know what it entails. The best protocol for building a scalable instant messaging chat server. I have no idea. I would use WebSockets because I'm just used to that. But to make it scalable, I have no idea. Good morning, Abdulali. My favorite programming language is probably JavaScript. Nice, Inceptions. Thanks for being here. All right, back to what Doc has written. Push that back to the output stack. Once the algorithm completes, the output stack will have a single item, which is the completed AST. Are we done? Is there any leftover? Yeah, output queue. Do I have any other occurrences of output queue? I don't. At this point, we shouldn't have an operator stack left, right? Like, really, we just want to return the output stack dot pop, because there should just be one thing left in it, right? That is the entire tree. I think this is saying if there are extra operators left over, but at this point there shouldn't be, because we're getting rid of, we're removing them and putting them into the output stack is operations. I'm just going to try this. Output stack. Dot pop. Should be it, right? And does that give us back our tree? So, let's see. We did parse arguments. That's great. Parse subtree. We don't have these functions anymore. Now we literally just have pass one. So if I did something like no input, and then the expression with parentheses, like this, that should give us back this abstract syntax tree. So if I do compiler.pass1, with that, we should get this back if we've done everything correct. Let's comment out the rest of our tests. Converts an expression to RPN. Oh, yeah, we're not even doing that anymore. So let's get rid of all these. Okay, let's see what happens. 3,000 vulnerabilities? What? And thanks for the follow, Faceless Bard. It was the dependencies I have are just Jest, I think, right? Jest and ESLint. There have been quite a few vulnerabilities found recently. Like there's that Acorn library that a bunch of things were dependent on, and it had a vulnerability in it. Fixed most of them. Okay. All right, let's try running the tests. It works. It creates an AST subtree for immediate values. Okay. And so we can have our input A like this. And then we say compiler.pass1. With that, I believe that's how the input would work, right? Yeah, you have brackets, input A, and then your expression, 21 plus A. Oh, if there's anything left in the operator stack, that makes sense. But for simple equations like this with just two values, it's gonna be pretty simple. So this should work, but once we get into things like this, we'll probably need to do that. So we'll do that. But oh. Let's see. A is immediate 21. And are we saying it's an arg? Yeah, arg and then argzet token. Okay. Yeah, I'm just surprised it worked on the first try, but apparently there's more things we need to do. And thanks for the follow, VTempro, and thanks for the follow, JJ Cooper. Yeah, I'll do this really quick. So while the output stack... Oh, while the operator stack has a length, we'll say push operation. And then there should only be one left, and then we pop it. Does that fix our issue? It fixes our issue. Thank you, Doc. It's crazy. It's crazy. Thank you, Jake Hoover. So doing that made it work because it didn't have brackets. But if we put brackets around it, it probably would have worked. But I think that was why. Yeah. All right, I'm gonna leave it as is. This is crazy. We've got ourselves an abstract syntax tree. So I'm eager to test this with much more complex inputs, but I think we're done with pass one. B-A. Oh, look at that. And so look, I didn't put a space there. Let's see if the tokenizer can still handle it. No. Do we need a space there? I guess we just got it backwards. Like, this wanted it to be A and B, like that. Yeah. Cool. All right, now it gets a little more complex. Yeah, rockets go up. And thanks for the follow, Marquis. Try 5 minus 5 minus 5 minus 5. The only thing is I would have to write my own tree for that, and I don't know if I'm ready for that. Let me see if this works, though. X, Y. I want this to be pass one. And we'll uncomment the test. Crazy. Doc is a genius. Okay, thank you. I was like, I don't want to write that out by hand, but if you give it to me, I'll try it. It should handle lots of 5s. So let's just do that. So here we go. This is the tree of the operations with a bunch of 5s. And we need to create a compiler instance. And we will say expect compiler dot pass one with the 5 expression, which we'll get, to equal this. And what's the expression? 5 minus 5 minus 5 minus 5. Did I say enough 5s? All right, here we go. No! It should handle lots of 5s. Where did we go wrong? Are you sure you gave me the right tree, Doc? And thanks for the follow, Makodi. Look at peg.js. You can build an AST from a defined grammar. I've used it to build a rule engine. Interesting. I'm not like super interested in compilers and parsing, but this is just one particular problem that seemed pretty interesting. Let's see what happens if we put parentheses around it. No, it still breaks. Let's do this. So this is what we generated. Should the tree contain a? There are no variables. So I think mine it's doing it, I guess, in the reverse order because oh no. So this would be 5. No, we should have seen 5 minus 5 somewhere. I guess if we look at the deepest tree. Yeah, so this is the deepest tree right here, which is 5 minus 5. So that's the deepest tree, 5 minus 5 right here. And then that's being subtracted from 5, but that's actually B, so it's on the right-hand side. Check your tree, Doc. Because it looks like mine's doing somewhat in reverse. Yeah, like you have 5 and 5 up at the top, whereas mine has it at the bottom. Yeah, so with docs, the 5 minus 5 operation is like at the top of the tree, whereas mine was like a deeply nested node, I guess. Yeah, every node needs an A and a B. Those are the two operands. Oh, Joey Devs with a 99.81. I mean, it's a very high score, but we've seen someone get a 99.99. Actually, have we seen somebody get 100 before? We might have seen somebody get 100. So it should be left to right, yeah. I am completely shook. All right, let's look back. Oh, I think we have seen someone get 100 before. Okay, so let's see if we look at my tree. So if we do this operation first, that's going to give us 0. And then if we do this operation, 5 minus 0 gives us 5. And then if we do this operation, that's 5 minus 5, which gives us 0. And if we do this operation, it's 5 minus 0. So this tree gives us back 5 instead of negative 15. What on earth? Oh, wait, your tree is wrong? 5 minus 5 is 0. Minus 5 is negative 5. Minus 5 is negative 10. Yeah, so this should be negative 15. Did I do that math right? Okay, but send me the right tree. Let's see if I got it right. All right, while you're doing that, we're going to keep going and try these out. Pass 1 with X and Y. That works. Tree was right, math was wrong. Okay, my math was wrong. Good. Thank you, Jitesh. So that works. We can do 2 expressions within nested parentheses. What happens if we add some extra parentheses? It should still work because our RPN algorithm that we wrote takes care of multiple parentheses. Yeah, nice. All right, what's up next? Ooh, nested parentheses. Pass 1. X and Y. The correct tree, hopefully. So that works too. So I'm pretty excited that at least the test cases are passing. Wait, is it still wrong? Oh, you copied like a... I think you've just doxed yourself. We know what your name is now, Doc. Thank you. I guess it's not technically doxing. All right, let's try it. Doc is a mod. You can delete your own message, Doc. Oh, did I not remove the X? Oh, I didn't remove the X, did I? I still think my tree is wrong, man. Yeah, I still think I got that one wrong. Yeah. So apparently I can't handle an equation like this. I wonder why. I'm gonna comment out that test for now. We'll come back to it. You know what I need? I've thought about, for my chat manager, creating an auto translator similar to the auto translate bot. I do not. Does anyone else here speak Russian? All right, let's keep moving. Create an AST subtree with more than one operand. Pass one. It's the fives all over again, right? Let's see what happens. Invalid. Oh, I didn't pass the argument list in. No arguments. Yep, it's broken. Good call. So we know when things like this happen, it's broken. I think we're going in like a weird or the wrong order. We'll come back to it. It seems to be working for the more complicated cases, like nested parentheses and nested expressions. But yeah, let's see. Cool. And then we have handle lots of fives, a subtree for more than one operand, and create an AST for mixed operands. Wait, which one did we? Oh, this one. A subtree for mixed operands. Does that work? Yeah. All right. What are we doing wrong? In the case, I'm gonna change my precedence function. Okay, that's probably it. So what we're looking at is if this token has higher or same precedence as another token. And we can look at my precedence function, which may not be right. So help me out with this. Same precedence, we'll take in two operators. If... Oh, this is wrong, isn't it? If operator is multiplication and operator 2 is division, that's not the same precedence, or is it? I thought division had a higher precedence than multiplication. Precedence has a C. Precedence. Oh, now it doesn't exist. Precedence. There you go. So given multiplication and division would come first, and given addition and subtraction would come first. They are the same? Okay. Addition and addition. Oh, I guess I need to handle that. Parentheses, exponents, multiplication, division, addition, subtraction. But yeah, you're right. I don't think I'm handling if they are the same token. Same precedence. So if they equal each other, then they are the same precedence, right? All the other tests still pass. Can it now handle lots of fives? Hey, that was it. Thank you, Jitesh. We were checking the comparison, but we never checked if it was the same operator itself, which gives it the same precedence. Very good. All right, it should handle those threes now. Hey, where are those threes at? Right here. Yes, yes. Okay. We're doing it. We're taking this and compiling it into an abstract syntax tree. That's fantastic. Okay. Where are we at? We have more guidance from Doc, who says, for passes 2 and 3, you can actually make these one-liners with the help of this function. I have no idea what the heck is going on. Yeah, me neither, architects. We're basically, we've been gifted a set of instructions, and we're using these instructions to modify our computer program to get it working. It's reduced, but for abstract syntax tree. So, side note, you can see how this is now a pretty generic algorithm for parsing any expression, and the magic is all inside that precedence function. Yeah. Yeah, it's great. A parser. So we are coding this thing called the tiny 3-pass compiler. This is a problem on codewars.com, which has a lot of coding problems. But basically what we need to do is we are writing a program that can parse a mathematical expression. So we're writing a program that can take in a string that looks like this, which is like a math expression, and turn it into a thing called an abstract syntax tree. And an abstract syntax tree basically just describes a program. It describes what are the operations that are happening, where are the variable lookups. So we're converting this string into an abstract syntax tree. So like this very simple expression here, 21 plus 21, gets turned into this tree, which has an operation which is plus and two operands A and B, which are both just numbers. So that's what we've got working so far. The bulk of the work we did like over a month ago, and today we're just fixing it to actually make it work in the right way. But it can get much more complex than that. Like you can take an expression like this and turn it into this tree, or an expression like this and turn it into this tree. And then the next step is, once you have this abstract syntax tree, is pass 2. So the first pass takes the program, tokenizes it, and turns it into an abstract syntax tree. The second pass will return the abstract syntax tree with constant expressions reduced. So I think essentially, if you have an operation that's between two immediate values, like in the case, like that very first case I showed, if you have an operation that's 21 plus 21, you want to reduce that down to the value 42. It's episode 42! Not exactly. I'm figuring that out in my head right now, but I think that's, so what they're saying is for pass 2 is, any operation that would result in a constant value gets reduced into a single operand, I guess. And you do that for the whole expression. And thanks for the follow, Architects. And thanks for the follow, Hot Hands. I'm pretty sure I'm only just barely hanging on because one time 3 years ago I did a Code Wars or Hacker Rank about reverse Polish notation. Nice. The tough part was last time when we converted the expression into reverse Polish notation. So here's the other interesting thing for anybody that's just stopping by, is like when we write out mathematical expressions like this is known as infix because the operands, like the plus and the division, are inside of the equation. But there's another way to write it called postfix, which looks like this. So instead of writing 3 plus 4, you actually write 3, 4 plus. And when you write it that way, it's much easier for a computer to actually calculate it. I shared a video earlier that talks about it in depth. Wait, is it this one? No. RPN. There it is. Watch this video. This guy is great. He does a ton of really good explanations of like computer science concepts, but he explains the difference between infix and postfix. But basically what we've done is we have converted infix to postfix, and by converting it, it made it fairly easy to turn it into an abstract syntax tree. How the heck did I learn how to do all this? I've been programming a long time. And also we have really smart people that are watching and helping. Doc, who's in the chat, sent a message on our Discord with just like a breakdown of how we can take the code that I wrote last time and convert it to work and turn it into an AST. Yeah, exactly. And that's the other thing. So right, that website that I showed you, Code Wars, it has problems ranging of many different difficulties. 1Q is the hardest this is one of the hardest problems you can find on the website. But they have 8 Qs, which start you off much easier, and you kind of just build your way up. Today is also okay for you. It's 4/2. It's not quite April 2nd for me yet. Pass 2 and pass 3 both become reduce AST, where function value and function op are functions to apply the values and the operators. Cool. Yeah, go for it, Architects. I mean, and if you take a look at, because this is episode 42. This is the 42nd time we've done this. And so if you look at playlists on Code Katas, we start off with some pretty simple problems, and like they gradually, every now and then we'll do easier ones, every now and then we'll do harder ones. But there's a plethora of them to choose from. And typically what I like to do when I'm solving easier problems is I break it down and solve it in several different ways. So if you're a new programmer, you can, or new to JavaScript, you can see how to do things like that. How do I deal when I'm struggling trying to learn something new? Just have to be persistent. I think that's one of the biggest things about being a programmer is being persistent. Okay, I want to read, what do we do in pass 2? And thanks for the follow, Dragon. Wait, no, not C#. JavaScript. Yeah, so you can. I typically do it in JavaScript, but they have all of these different languages. C#, Java. Do they have? Yeah, they have Haskell. It'll vary for each problem what languages are supported because these are user submitted problems. Yeah. Okay, first pass takes a string and will return a JSON object. The second pass will be called pass 2. This pass will take the output from pass 1 and return a new AST in the same format with all constant expressions reduced as much as possible. So for example, if the function is x plus 2 times 5 pass 1 gives us these two nodes, A and B for the values 2 and 5, but pass 2 simplifies that. So it then becomes the argument X, or that arg, plus 10, because that got reduced. Okay, I think we can do this. We basically have to traverse our abstract syntax tree, and anytime we come across an operation between two immediate values, we actually perform the operation, and that results in a new node with just that one value. So this entire subtree collapses into an immediate value of 10. Yeah, okay. Is it recommended for someone who is still at a beginner level to study bit manipulation? It's up to you. I mean, if that's relevant to your job or how you program or the kinds of problems that you're solving, then sure. I mean, it's once you start to do it fairly often, it'll start to make more sense. Like for me, I don't really ever do bit manipulation or bit shifting or anything like that. So it takes me a little while to understand what's happening, but if I put my mind to it, I could figure it out. So we're basically writing an eval function that goes as far as possible. Eval of an immediate number node is just the number node unchanged. Eval of an op is doing that operation. So write two functions that fit into reduce AST. Well, thank you, architects. My favorite JavaScript framework is Vue.js. The best way to learn is to find problems that you can more easily engage in. Yeah, so do things that interest you, really, if you can. We're not all that lucky. Okay. How long have I been working on this problem? Because I'm excited that we've at least... Look at all these passing tests. We made it this far. And I did say I was only going to work on it for 45 minutes. I'm trying to think... If we look at past 2 and 3s, so we're looking at the node dot operation. If it's an argument or if it's an immediate, we figure out the value. If it is an operation, then we do a recursive. That's not a recursive call. We're so close, so close. We do an invocation of this function with the operation and the recursive call with the left side and the right side. Huh. So this is for pass 2, right? Because it's still going to create an operation, or is that actually evaluating it? All right. I'm going to look at your example that you sent. Replace operators with this function. Replace leaves with this. Okay. Okay, we figured that out. I know that I'm so close, but I think I might actually go. I don't know. Will you be mad, Doc, if I go? Does DigitalOcean have an application? Oh, no, this isn't DigitalOcean. This is my break timer. This is Logitech, which is for my webcam. This is my VPN. This is sharing my mouse. These are some stats. This is Hyperswitch, which is how the previews show up whenever I switch. This is Alfred, which is what I use for launching things. This is Spectacle, which I use for moving things around on the screen like that. That's about it. Is that the one you were talking about? I don't know. Hey, Tejas, don't go. All right. You're just giving us the answer so we can finish. Let's plug it in. I am standing. Yeah, the camera's at a weird angle, so it looks like I'm sitting, but I am standing. Eval operation takes in the operation A and B. Yeah, easy enough. We need to call this on every node though, right? Oh, it's a reduce. Wait, what? So we pass in the AST. So what is this? This is a function. This is another function. So I have to implement reduce AST. Is that what we're saying? Yeah, and then eval op is easy enough. I could write that really quick. That's basically like this. So we have all of our operators. And so this is a function that takes in A and B and returns A plus B. Operations. We will do it. So I could say in is operations at, wait, what was it? Op with A and B, like that. And then we need to just write the reduce AST function. And let's see. So I think he's giving us the answer, but oh, that's literally the one that you shared here. All right, I think you've given us the entire answer. I think that's fine because I have been dreading having to implement this thing. Yeah. All right. That's it. We're done with pass 2. Let's see. We have one test that can test for that. Should do pass 2. Let's see. Oh no, it broke. Oh, because I just have to say 2 equal, not 2 deep equal. Those are left over from like Mocha and Chai. 2 equal. Cool. We catch up. The circuit board. If you look on Twitch, there's a description of the stuff happening. But basically, this is a Connect 4 game, and it's YouTube versus Twitch. So all the red chats you see here are coming from YouTube. And let's see whose turn it is. It is Twitch's turn to play. So you can do !C4 space and then a column 0 through 7, and you will drop a blue dot on that given column. And then the other thing, yeah, Happy Phone just went in column 7. Nice. Now it's YouTube's turn. And then the other thing is an 8-bit LED. So if you do !LED followed by 8 zeros or 1s, it will turn on the corresponding bit. Wait, what? I thought we fixed that. Oh, we didn't save the file. Thanks for the follow, Renfolds, and thanks for the follow, Lukey. Oh. Gotta throw in expect. Expect compiler pass 2 to equal pass 2 result. Welcome back, Happy Phone. Oh no! A one-liner, a very long one-liner. Oh yeah, a dot in and b dot in. Good call. That's why. So in the result, we're getting like object object. So the actual value from the A node and the actual value from the B node. Plu says, you're a huge reason why I code. Can you say hi to my friend? No, I can't, Plu. We gave you one chance. We gave you a chance, and you lost it. Oh, it works. What are my thoughts on Golang? It's cool. I'm not an affiliate yet on Twitch. I'm currently multi-streaming. I'm streaming on both YouTube and Twitch. And whenever you're an affiliate, you can't actually do that. So pass3 is another reduce with 2 even simpler functions. Okay, I think I'm gonna call it there. We have huge thanks to Doc. If and when we come back to this problem, I want to write this myself because Doc wrote this code. I want to write it myself. I want to understand. I mean, I for the most part understand what it's doing. It's basically taking a tree with a lot of nested nodes and trying to create as few number of nodes as possible. Yeah, Jitesh, thanks for dropping by and thanks for all the help. So that's what this is doing. Yes, huge thanks to Doc. Everyone give a thank you emotes. thank you, Doc. But I'm curious. The next step in this is to convert it into a program that looks like this, because then you simulate the program. So the third pass takes the abstract syntax tree and returns an array of strings. Each string is an assembly directive. Yeah, so we're compiling this into an assembly language of sorts. Yeah. And then they give you the simulator for that machine code or for that assembly code. So basically, you just have to take your reduced function and turn it into, or sorry, your reduced tree and turn it into assembly code, which can then run on this simulator. We're not far off, but we'll do it. We'll do it next. Oh, YouTube won Connect 4. Great work. Let's see. Yeah, nice work. Good job, YouTube. Yeah, thank you, Doc. And welcome back, Andrew. I don't know when I'll be live next. I have ideas. There are things that I want to do. I want to do a comparison video of React and Vue, like build the same app, and potentially vanilla. I've done this in the past where I built the exact same application using multiple different front-end frameworks to compare and contrast. Coding Garden front end framework showdown, I think I called it. It was like 2 years ago. This thing, the front end showdown. We could do Vue 2 with the composition API plugin. So we could do it in the style of Vue 3. And that's probably what I would do. So that would be the update to this. So this was over a year ago. It's probably a year and a half ago. But this time we would do React with hooks because we didn't do that last time. We would do Vue with the composition API. And then we probably could do web components for vanilla JavaScript because last time we just did like DOM manipulation, but it would be cool to see web components. That I want to do that. That's on the horizon to do a stream like that. And what do I think of Angular? I haven't touched Angular probably since this stream. So I would want to take a look at the latest Angular and see if anything's changed. I'm curious, do they have anything like hooks or the composition API in Angular? I don't know. Oh yeah, it's April, isn't it? I don't know. jQuery. And that was another idea for a stream. We could build jQuery from scratch. It wouldn't be the full jQuery library, but just like selecting changing styles, having like a collection of things that you can change multiple properties on, like the way jQuery works, but building that with vanilla JS and vanilla DOM manipulation. That would be fun. That's another stream idea I have. And then we're working on the inventory app, so we're going to stream that at some point. And the intro to React hooks that we did the last stream can get much more complex with more components, so I want to do that. I have ideas. So there's streams incoming. I just don't know when. And hello, Asterix, if I didn't say hello already. All right. Let's see. Doc says, do I want to see past 3? Most of the work is actually reading the long description. The actual code is really short. The AST maps directly into... Oh, I see. I mean, we could solve it. You're making me want to solve it. Because basically, yeah, like this is the result of past 2. And then I guess we go to like the leaf nodes. And we say immediate 10. Right? SW is swap. And then AR is input, so 0. And then at AD is for addition, right? So it's really just converting this into a assembly code of sorts. Let's do it next time. We're going to do it next time, Doc. With modern JavaScript, jQuery works more like a code sugar instead of actual advantage. Don't I think? Yeah, I mean, with modern DOM manipulation that's supported by the majority of browsers, you can do a lot of the things that jQuery was doing, but there are still things that jQuery can do that regular DOM manipulation doesn't really do by default. So yeah. Oh yeah, that's gonna be fun when we start querying the database and such. We need to figure that out because I totally spaced. Like the past 2 months, we didn't do an avocado stream, so I'm probably gonna try to do at least 2 avocado streams this month as well. I reached out to the avocados and I haven't heard back from them. So we'll see. And if you're wondering what an avocado is, you can join as a member on YouTube. And avocados are a tier where all of the avocados, right now I think there's 3 or 4 avocados, those 4 people get to vote and decide on a live stream topic that will happen. And it will happen. But that hasn't happened. And I haven't heard from them. You can also join on Patreon as well. And it's slightly cheaper on Patreon because YouTube takes more money from me. So you can be a $25 a month avocado. Next stream, let's say, what is today? It's only Wednesday. Either Friday or Saturday for sure. Allow viewers to change the brightness on the LED command. I could do that. The thing is, I actually reduced the what's it called? Exposure. So that's one aspect of it. But yes, we could technically control the how much current is going to each LED to change the brightness. Yeah. Can't unmute you. We're gonna go. All the operator nodes are directly replaced with add, su, mu, or d. Yeah, that makes sense because those are the operations. And like in assembly language, typically there is like an add or a subtract operation that can happen. Yeah, I guess I'll go ahead and say it. No, I'm not gonna say it. I'm not gonna say anything. Pulse width modulation. I vote we allow space separated images for the LEDs so that users can post an animation. Yeah, I'm not gonna say it. I'm gonna go. Let's find somebody to raid. Looks like Sika Player's live, and Mayuko is live. Doesn't look like she's coding though. What's Sika Player doing? Twitch music app with React and an API. Let's see if there are any other live coders on. And also, if you're watching on YouTube, head on over to twitch.tv/codinggarden. Night Doc, thanks so much for your help. Much appreciated. So, if you're on YouTube, come over to Twitch. We're going to raid a channel. And good night, Happy Phone. Good night, Unhot. Let's see who else. There's PseudoKid. It's building a web app with push notifications using React and Elixir. Interesting. Quality Coder. It's doing a Twitch whisper system. Good night, Fiddick. Thanks for hanging out with us. See if there's anyone else in the science and technology category. Oh, that's me. Look at that person. 8 a.m. I better. Did you stay up all night, Merchon? Code help and mentoring. See you later. Python network inspection. Kyle Smith is building. There was a Kyle Smith on YouTube earlier. Is that the same Kyle Smith? All right. Oh, Linus Tech Tips is live. Okay, I think we're just gonna raid Sika Player. So Sika Player is usually, I mean, I haven't actually tuned into his channel in a while, but typically he's learning things. So he's pretty new. So when we go over there, you got to be nice. You can help him out, setting up a raid plan. And so if he needs help with React or JavaScript, help him out. And thanks everyone for watching. This was super fun. Huge thanks to Jitesh and Doc and anyone else that provided input. Shout out to everybody that participated in coding game earlier. That was super fun. We have to do that more often. This is just a fun time all around. Alrighty, everyone. If you followed, be sure to watch the credits. You will see your name pop up on the screen. And wherever you are in the world, have a wonderful morning, afternoon, evening, or night. And until next time, here's this.